Hey guys, and welcome back to the A-Level Mastery Series. This time we're here with an exponential slash logarithm question. Now the reason why this topic is kind of brought up into one is because you can't actually have logarithms without exponentials. So in every single question I've ever seen ever, they always put some kind of question where you have to rearrange something. So we have an exponential here, but I'm willing to bet that we're going to be using a logarithm. Likewise, if it was a logarithm question, they always put a part where you need to work out the exponent. Okay, so if we have a look at this question, we have an equation here that has everything that's unknown, but our two variables are h and t. So we have a, b, and k, which are unknown constants that we are unaware of. So when a tree of a certain species was planted, it was 2 meters in height. So what I'm going to do here is, as I go through, I like to highlight the information. So when it was planted means when t equals 0, because it says t is the years after it was planted. So when it's first planted, of course, there's no time that's passed. Then when t equals 0, we have h equals 2. And after 2 years, its height was measured at 3.81. So that means 2, h equals 3.81. Just like that. Okay, so we've already got some information that's quite useful. The height h meters of this tree, t years after it was planted, is modeled by the equation h equals a subtract b e to the minus kt, where a, b, and k are positive constants. Cool. Given that the species of tree will reach, in its lifetime, a maximum height of 12 meters, find the value of t when h equals 10. Cool. So, as you can see, this is what I mean by using logarithms, right? Because t is in the exponent over here, we're going to use logs to rearrange that. So, of course, the problem here is that we don't know what a, b, and k are. So I can't just sub in h equals 10 and then try and work out t, because I'll get a bunch of algebra. So I need to work out a, b, and k first, which is exactly why this is 10 marks. Now, if I sub in t equals 0 into this equation, remember that means this exponent here, this exponential, will become 1, which means I'll have two unknowns still. I'll have 2 equals a subtract b. So I can't use this first one just yet. The second one, well, it's going to be the same issue, except even worse because we'll have k as well. So we can't use these two pieces of information yet, because they'll provide me equations that have more than one unknown. But there is another piece of information. Given that this species of tree will reach in its lifetime a maximum height of 12 meters, so what does that mean? Well, if we're talking about in its entire lifetime, you might be thinking, well, how do I know what the lifetime of a tree is? Well, you don't need to know. The idea is that the maximum height of the tree is actually just going to be a. Think about it. As time goes on, if you think about the exponential, negative exponential function, if I draw it out here, it's going like that. It's an exponential decrease. So initially, we are subtracting the biggest possible amount from a when it's first grown. So the height is going to be very, very small because we're subtracting the biggest possible number. And as time goes on, the amount that we're subtracting exponentially decreases. If you'd like, you can even sub it into a calculator, right? E to the power of 0 gives me 1. But e to the power of anything that's negative, so let's say minus 1, has to be smaller than 1. And as it gets bigger, so if we do to the minus 10 now, as you can see, the number's getting smaller and smaller and smaller. So in other words, all I'm trying to do is see what happens as t goes to infinity. Because remember, since this is infinitely decaying, no matter how long the tree lives, the idea is this term here is going to go to 0. It's going to disappear. Okay? Then h is just going to equal a, because as we increase that value of e, this whole term is getting smaller and smaller and smaller. 10 to the minus 44. And it's getting there faster and faster and faster. So that's how we use that piece of information. It says it will reach a maximum height of 12 meters, so that means 12 is equal to a. Now this actually makes sense in terms of the structure of the equation. If you think about it, they're trying to use this equation to show what the height of the tree is t years after it's planted. We can see that as t increases, this thing here gets smaller, which means we're subtracting a smaller number. So it makes sense that a is actually the starting or the maximum value for the height. So you don't actually need to do this maths. You could have deduced by inspection that a is going to equal the maximum height. Because I mean, hopefully that makes a bit more sense. But even if you didn't understand or can't logically inspect this equation to figure out that a is the maximum height, you can just sub in a good old-fashioned value by seeing that t, as it increases, makes e exponentially decrease. Perfect. Now, if you remember rightly, this equation here originally had two unknowns, but now we know what one of the unknowns is. So we're going to use this expression now. So when t equals 0, h equals 2. If we sub that in, we have 2 equals 12 minus b. Why? Because e to the power of 0 equals 1. So that's going to be b times 1. There we go. So swap that around, we're going to get b is equal to 10. And now, finally, so we've used this last information, this piece of information, we're going to use this piece of information to find k. So when t equals 2, h equals 3.81. From here, it's going to be relatively easy. 81. It might be good to rearrange the equation first, which might... should we do that? Let's rearrange the equation first. So at the moment, we have h equals 12 subtract 10 e to the minus kt. So let's rearrange for k, because that's basically what we want to work out in this case. So let's subtract 12 from both sides. We have h minus 12. Actually, I'm going to do it the other way around. I'm going to move this to the left side and this to the right side. So that gives me 10 e to the minus kt equals 12 minus h. So then e to the minus kt equals 12 minus h over 10. Take the natural log of both sides. We get negative kt equals ln 12 minus h over 10. So then t, no, we're not looking for t, we're looking for k. H over 10. So now we can sub in all our values, and that makes our life a hell of a lot easier. Now, again, remember the purpose of these videos is to show you my thought process and how to get an A star. So it really is about kind of clearly labeling the information that you have and then thinking ahead. So there are students that would have subbed this in, realize they can't do anything, and then panic, sub this in, realize that that's even worse, and they get confused. So it's good to think through what you want to do first by labeling the information and then imagining what happens. That's all I've done in this case. 12 minus 3.81 over 10 over negative 2. So let's quickly sub this all in. So we have the natural logarithm of 12 subtract 3.81 over 10, and then divide by minus 2. Gives me 0.0998. And then some other stuff, we will leave it there to 4 decimal places or 3 sig fig. Now, finally, we can work out the value of t when h is equal to 10. Now, here's where we can be smart. I can just swap these two around to find my equation for t. I don't need to rearrange the whole thing again, which I have seen students do. We know that t is equal to ln 12 minus h over 10 all over negative k. Because again, I could times both sides by t, divide both sides by k. That gives me ln, and what was the value when h is equal to 10? So 12 minus 10 over 10 over minus 0.0998. Let's sub this all in. So we have ln 12 minus 10. I could have just said that's 1.2, but either way it's fine. Minus 0.0998. Yep. 16.1 years. Because remember, we want that unit. And that right there is 10 marks. Now, in my opinion, the actual maths, once we get going, is not the difficult bit. And that is, hopefully you've seen, as a common theme with these videos. Whenever I point out these A-star videos, the maths itself is not the issue. I'm assuming if you're watching this series, rearranging exponentials and logarithms is not the hardest thing in the world. In fact, this isn't even the hardest rearranging I've seen. There's a harder rearranging question I could have shown you, but it wouldn't be as hard as this question. Why? Because this relies on application. And with GCSEs, most of you learnt by learning methods and memorizing it and saying, oh, well, if this is the case, then I use this. If this is the case, I use this. Very machine-like. This is where maths becomes a bit more creative. You have to use your problem-solving skills, okay? Because again, this is very different to what they've given you before. The math skills are all the same, but the beginning bit is the tricky part. And if you look at it, the beginning bits are jokes, right? They're not even easy. These first two steps, which will give you 4 out of 10 marks, by the way, is a joke, right? 12 equals A, B equals 10, it's very quick. But again, it's not about the maths being hard, like the numbers, it's about the actual concept and the application, which is the tricky bit. A lot of students got this question wrong. This is a very, very hard question, all things considered. So again, when you're going through these questions, highlight the information that they give you and then think about what makes sense to go first. Don't just jump straight in. Take a second, just like I did. I said, well, if I use this, there's 2 unknowns, here is 3 unknowns, but this, I only have 1 unknown. You should also always use the fact that they have to give you enough information to get the answer right. So if there's 2 unknowns here, 3 unknowns here, it means this last piece of information has to be the way to get the first unknown, because otherwise the question's impossible. So keep that in mind, and I'll definitely see you in the next question.